Python is one of the world's most popular programming languages, but much like C and C++, it's often too big to fit on microcontrollers and embedded systems. C++ solution is Arduino, and Python's solution is MicroPython. So what exactly is MicroPython? Well, it's a lightweight implementation of Python 3 made for low resource devices such as microcontrollers and embedded systems. RP24s, which are used by Picos, ESP32s, even 8266s, anything that uses ARM Cortex Ms, and STM32s, among others. It was created between 2013 2015 by Damian George. The first version was released in 2015, and it was adopted by the ESP32 and ESP8266 a year later. The earliest version was based on 3.4, but more recent versions have gone from 3.5 through 3.8 and beyond. The Pico that came out in 2021, it supported it right out of the box, which greatly increased the popularity of MicroPython. And then there's CircuitPython that was forked from MicroPython in 2017 by Idafruit. It's an even more simplified and beginner-friendly version with a real emphasis on Idafruit products. It also has a thing called Ripple, or at least that's how I'm going to pronounce it, which is read, eval, print, and loop. It's a mini interactive programming environment that can be accessed when a microcontroller is connected via USB. It's even more useful than Arduino's relatively simple serial monitor. This allows you to program, debug, and evaluate programs line by line. It still suffers from a number of disadvantages, like Python. It has an even slower execution time than Python, more memory usage in general, and the usual dynamic runtime errors that you may encounter. Now let's compare MicroPython to Python. Python generally needs a bare minimum of about half a gig of RAM, but honestly, it's usually something closer to 1 to 8 gigs for good loadout. Usually needs at least 100 to 300 megs for very minimum installation. It also assumes Windows, Linux, Mac OS, either 30 or 64-bit, x86-64 or ARM 64. There is some support for some older stuff like ARM 7. MicroPython, on the other hand, can work with as little as 64 to 256 kilobytes of RAM. That lets out things like the Arduino Uno 3 and half to a full meg of flash memory, although the boards that support it do have some more resources than that. MicroPython's core firmware footprint is only actually between about 200 kilobytes to 1 meg, so the rest of the flash memory is for whatever you need for other things like the program itself. Python supports well over 500,000 libraries. Python really only supports a small subset of that, about 30 to 80, and maybe another 100 to 1,000 third-party libraries. Um, Many third-party libraries, in fact, have to be completely rewritten to be used with MicroPython and its limited resources. MicroPython, and I can't stress this enough, it's optimized for size, not speed. You're going to see even slower execution and no performance focus. Python doesn't focus on direct hardware access, although I guess it is possible. MicroPython does, on the other hand, since it's usually used on dev boards. MicroPython usually uses the smaller IDEs such as Thorny, and it usually handles its debugging through Ripple. So what carries over for Python? Well, pretty much most of everything does. Very relatively few exceptions. So I'm not going to cover everything again. Just check out my Python videos for everything about Python. All the basic syntax, grammar rules pretty much work the same. Variables, data types the same. So all the fundamental data structures work the same. Flow control, conditionals, loops, exceptions, functions, classes, objects, methods, everything. Keep in mind some libraries, even if they are common for Python 3, might not be available, so always check. If you get into object-oriented programming, that works the same. Pretty much if you can program it in Python 3, you can probably program it in MicroPython. There are always exceptions to that rule, but there still may be workarounds. There's obviously, when it comes to like memory limitations and such. Speaking of that, there are special considerations for MicroPython. Memory is a limited resource for the most part on any platform you put it on. Now, it is possible to put it on a desktop for, I guess, prototyping, testing things out, whatever. But if you have it on a development board, every byte counts. Large lists may just throw a memory error exception. Large strings consume a lot of RAM, which is precious. Multiple objects fragment memory. So there's a couple of best practices for MicroPython that set it apart. Make sure to just reuse variables. Don't use unnecessary variables. Don't use unnecessary copies. Process data in big chunks. This avoids unnecessary fragmentation. And keep in mind, memory optimization should always be your key when working with MicroPython. Um, More hardware direct interactions. You're going to have to figure out specific pins references for specific boards. Do not assume that a MicroPython program is going to work flawlessly from one board to another. You can also run into power consumption issues here. When we run Python, we're usually running it on a computer and it's running, usually often running off mains AC or a very powerful battery. Even on a laptop or a tablet, you could be running this for many, many hours, full power usage minimally. But when you're dealing with a dev board, power consumption can be a real issue, assuming you don't just have it plugged into mains. You could be running off very minimal power. You might have to factor in low power and sleep modes into the program. Now, often with a development board, you're going to be use the machine library. Technically, it's a module, not a library. You may actually get somebody giving you quite an argument if you call it a library. Yes, I've been there. It provides a pretty complex hardware abstraction layer, or a HAL, and this gives you direct access to a microcontroller's peripherals, both external and built-in ones. Some of the things it has is working with pins directly, pulse width modulation, analog to digital conversion, UART, I2C, SPI. You got timers, you got real-time clock, you've got watchdog timers, stuff to do with deep sleep and sleep functions in general, reset and system control, and there's a lot of others too. Keep in mind, different microcontrollers, different dev boards, they're going to support different aspects of the library depending on the features of the board. If it lacks Wi-Fi, you're not going to be able to do anything with the Wi-Fi parts of the library. And in fact, different microcontrollers development boards may work somewhat differently with certain aspects of this. There's also support for what's known as closer to metal direct access, where you can actually directly access hardware registers. If you recall seeing this with Arduino. And then we have CircuitPython. I may eventually do a separate video on this, but the differences are relatively minimal. Now, the first thing is that CircuitPython firmware has the device appear as a USB flash drive when connected. Just open it like a flash drive. You open and edit the file directly. You put files on the flash drive, no complicated IDE. When you've actually put the files on there, it saves everything, it reloads the connected device, and there you go. All the USB features are just meant to work right out of the box without any need for further configuration. So if the device has native USB support, USB on the go, etc., mouse, keyboard emulation, MIDI drivers, etc., it'll should all just work. There's a large library creation collection that's been created and officially supported for by Idafruit. So if you really love Idafruit products, peripherals, and stuff, CircuitPython is a thing for you. Um, it uses board and digital I/O versus machine. Don't be too worried about this. You can still use machine as far as I know, but it is simpler and easy to use for beginners. There are some drawbacks. CircuitPython generally isn't supported on STM32 boards, ESP8266, many of the NXP boards, and there's generally no support for desktops. Again, this is a focus on Idafruit, what they sell, peripherals, um, but it doesn't mean that you only can use it with things sold by Idafruit. Now, just a brief mention on Walkly. Good news, you can program with MicroPython on Walkly. The Pico and the Pico W can be programmed with both Arduino and MicroPython. I believe any of the ESP32 models can also be programmed with either. There might not be starter templates for everything or nothing I could immediately find. You may have to just manually remove the INO file, insert your own Py files. But if you've seen your way around Wokke, it should be pretty simple. There's also support for Ripple and the serial monitor. You can also use Circuit Python with at least the Pico and presumably the Pico W. All right, here's a simple blink example on a Pico and Walkway with an external LED connected to GP5 ground. Now we're importing from, in this case, importing from machine and pen specifically. And then from U time, instead of time, we're using micro time. That's what the U stands for. We're importing sleep. So we're just waiting. We're doing a sleep here just to wait. And it's for the USB to connect. I'm not sure if this is just a purely walk weave thing or not. It's going to print a message. It's going to set an LED, particular pin. We're going to set it to out. And while true, it's just going to toggle it over and over again. Actually, pretty simple, even compared to Arduino here. So it printed our message down here. And it's blinking. All right, let's stop it. Well, let's see, Control C. Okay, this puts us into Ripple. Do help for more information. So we're interrupting the program, and we can do a soft reset of the board. We can do it again. Okay, pretty simple. Interrupt it again. There's a keyboard interruption here. We can do this on a real one as well. Let's see. In IO modes, some of the objects here, because it's already loaded, I believe. So we can do, I don't know, let's do, I wonder if this will still, yes, it will. Okay, so the program is already still loaded. So we can just play around with it if we want here. Let's see. Wow. One. I don't remember. Okay, yeah, there we go. All right, we stop it. So yeah, you can program right directly in Ripple if you want. Now here's something a little more advanced. I didn't actually write this. So we're importing for machine and we're importing time directly because we're not really caring about limited resources to this point. We're setting up where the onboard LED is on 25 on the Pico. And then we're setting pulse width modulation pin on 15 right here to this LED. And then we're setting a button on 14. We're specifically giving it a pull up resistor so we don't have to bother with that. That we normally put a pull up resistor on a button. We're going to have it work with two modes. We're also going to set a debounce situation here when the button's pressed. So it has to be set. It has to be pressed for a little bit of time here. So mode one, it's going to just fade this LED. Mode one, it's going to blink the onboard light. So yeah, pretty simple. Actually, you know what? Let me just reload this. All right, so in this mode, it's just blinking the LED. Now it's doing the fade. Okay, we switched it back. So a lot of this should already look familiar with from Python. Some things specifically to machine and time. Well, time, with sleep and whatnot here. Could also use U time if we wanted to. But yeah, we've got our button detection right here, and then we've got our stuff with the mode. Now it's going up to 65,500 and 35 right there. So it's doing it for 16-bit instead of 8-bit, I believe, if I'm doing the math there correctly. And then the blink is pretty simple. Yeah, it's turning off the pulse width, and then it's just toggling. So actually, what we could do is it is doing that. We can interrupt it. All right, let's do onboard LED toggle. Okay, toggle it. See, pretty simple. We can do. Oh no, I guess I can't do that. What did I do wrong? Oh, I mistyped. No, I can't do that either. Okay, so that is actually a particular. Okay, so that's actually just calling it something else entirely. Uh, hmm. Let's see. Do not. Actually, wait a minute. I got. It should tell me here up here. Whoops. Scroll. Yeah, that's the machine stuff. Okay, so that's what we can do. Deinitialize frequency. All right, gotcha. What is initially doing the mode? Okay, so I got it. I got it. Okay, so we can do. Oh, okay. No, I get it now. All right, so we could do. Whoops. Yes, there we go. All right, we could do it to 2000. It gets a little brighter and brighter. Damn it, it's almost nothing. There we go. So yeah, all of this is pretty interesting. All right, now here is an example with some Circuit Python. Not obviously seeing the whole USB drive interface or anything, but it's importing time, and we're using board and digital I/O instead. So digital I/O in out board, and then GP5, and then direction is output. For me, that's not necessarily any easier, but while true, we're doing a loop, putting on, turning on, sleeping, off, whatever. It's just blinking, or it should be blinking. There we go. And we still got ripple, but this is Circuit Python. This works just a little bit differently with Circuit Python. You can actually look up some of the specifics. So let's do help digital IO. But yeah, you see, you've already got the modules for everything kind of built in, as it were. So let's do value, false. Maybe that might not work. Not loading it in. Hmm. Okay, maybe it's not already. All right, let's just say digital IO in board dot QP5 value equal true. Okay. Oh, maybe I got that digital IO. Hmm. New. Hmm. Okay, let's do. Huh. Oh, wow. Okay. All right. Now for. Oh, we should be able to say, okay, true, false. Okay, goes back to the program. Now, just to wrap things up, MicroPython is a lightweight implementation of Python 3 made for low resources devices, such as microcontrollers, embedded systems. It really started to gain traction when it was adopted by the ES32, ESP8266. Then it really exploded when it was adapted for the Pico when it came out. CircuitPython is just a fork made by Adafruit. It's even simpler and easier to use, and it's focused on Adafruit products. Ripple provides an interactive environment for programming, evaluation, and debugging via the USB connection. Most of the MicroPython functions pretty much the same way as mainstream Python. However, many libraries are simply not available for MicroPython. Some libraries need MicroPython specific variants. There are many MicroPython specific considerations due to memory limitations, including some unique best practices. The machine module provides a hardware abstraction layer to access hardware peripherals with microcontroller development boards. Well, until next time, have a good one.